In this video, we're going to talk about how to use trigonometric ratios to find missing angles. What are trigonometric ratios? So those are just the ratios of sides in a right triangle. So we have sine, cosine, and tangent, and we're going to use this mnemonic to memorize or to help us to memorize these ratios. So let's say we can find sine of angle B in this right triangle. So we can pick any of the angles in this triangle. So we're going to work with sine of B. And according to this mnemonic, it's a ratio of opposite leg over hypotenuse. So opposite leg over hypotenuse. Cosine of angle B is the ratio of adjacent leg over hypotenuse, and adjacent leg here is A, hypotenuse is C. And tangent of angle B is the ratio of opposite leg over adjacent leg. So B over A. Now let's try some examples. And let's say we have the first example. We have a right triangle, and let's mark, let's say, this angle as angle X. The hypotenuse, let's say, we'll take as 7, and one of the legs will be 5. Now, as we said before in previous video, we always start with the angle. So in relation to this angle, what is given? This is the opposite leg, and this is hypotenuse. Now, let's just write this mnemonic on the top to identify which trigonometric ratios we're going to use. So, ka, to. So we have opposite leg and hypotenuse. So we're going to use sine. So we always start with the angle. An angle always goes inside the trigonometric function. So sine, cosine, or tangent. And that is equal to opposite leg over hypotenuse. So how to find x from this equation? So we cannot just divide by sine. So we have to use inverse operation of sine of x. If you look at your calculator, you will find something that looks like this. So this is called inverse sine. Sometimes it's called arc sine. And all what you need to do, in most calculators, you're going to press shift sign to get inverse sine operation. And you're going to put this ratio inside this function. And the calculator will find for you the x, right? So it will find the angle. So it basically, this function answers the following question. Which sine of what angle gives you 5 over 7? So x should be about 45 and 6/10. Now let's try another example. So I'll take hypotenuse as 18. Here I'll take 16. And let's work with this angle. So again, we always start with the angle. In relation to this angle, what is given? So we have adjacent leg and we have the hypotenuse. Adjacent leg and hypotenuse, we need to use cosine. So we always start with trigonometric function, cosine of x. X goes, the angle inside goes inside. And then we start with, continue with the definition. So cosine of x equals to adjacent leg over hypotenuse. So for this one, again, we're going to find inverse function. Cosine of what angle will give you 16 over 18? And that should be around 27 and 3/10. Let's try one more. Actually, we have two examples. I'll show you. I'm going to use the same angle and the same numbers. But here, I'm going to use 6 as opposite leg and 7 as adjacent leg. And on this picture, I'm going to use 7 as opposite and 6 as adjacent leg. And let's see if we get different results. So again, I'm going to write mnemonic on the top and start with the angle. In relation to this angle, what is given? We have opposite leg, we have adjacent leg. So we have to use tangent. Tangent of x equals to, use definition, opposite over adjacent. So for tangent, we also have inverse operation, inverse tangent. And again, press shift tangent on your calculator, and it should give you about 40. Hold on. Should give you around 40 and 6/10 of degree. Okay, now What if we have numbers in a different order? So 7 is the opposite leg and 6 is the adjacent leg. Let's start with the definition. Tangent of angle x equals to opposite over adjacent. So to find x, we need to use inverse operation of tangent, and that should be around 49.4. So as you can see, you will get different number. So it's really important to use correct order and stick with the definition. Okay, I'm going to just quickly revise a couple of examples when we have a missing side. Just a quick refresher. So if we have angle given, and let's say this side is missing and we have the hypotenuse, let's apply trigonometric ratios to find missing leg. So we always start with the angle. In relation to this angle, what is given? We have adjacent leg and we have the hypotenuse. So we have to go with cosine. Angle always goes inside. And according to the definition, it's a ratio of adjacent over hypotenuse. So the order matters. Here we can use a proportion. We can multiply each side by 12, and that would be 12 times cosine of 22. And by the way, if you write cosine of 22 first, your calculator will open parentheses. If you don't close it and you continue multiplying by 12, it will multiply inside cosine first and then take the cosine. So you have to close the parentheses. So you should get about 11 1/10. And let's try one more. Let's say I'm going to use 35 degrees here. Let's say 24 here and x here. Start with the angle. For this angle, this side or this leg is opposite leg, and this is the hypotenuse. So we have to use sine. Sine of this angle equals to opposite leg over hypotenuse. Now, the x now is in the denominator, so you have option here. You can use cross product and write that sine of 35 times x equals to 24, and then divide each side by sine of 35. I usually use the shortcut. So if I see that I have x here, I'm going to multiply these two numbers across and then divide by the number opposite to x. Okay, your answer should be around 41 8/10. And again, a quick check. Your hypotenuse should be the longest side. So it's longer than 24. It does make sense. Now let's try one word problem. I'm going to use the same word problem I used in previous video, and we are going to talk about Filbert Street in San Francisco. So let's say you know that you drove 500 feet and you went up by 150 feet. So you want to know the incline of this street. So it's the steepest street in San Francisco. So that's the missing angle. So again, we start with the angle. In relation to this angle, what is given? This is the opposite leg. This is the hypotenuse, right? So we have to use sine. Sine of this angle equals to, apply the definition, opposite leg over hypotenuse. So to find x, again, you can't just divide by sine. It's nothing. It doesn't make any sense. You have to use inverse operation. So you're going to put inverse sine or arc sine of 150 over 500. That will answer the following question. Sine of what angle give you this ratio? And your angle should be around 17.5 degrees. Now, I want to show you one more example. When we have several figures in the same picture. So let's say I have this missing side. I know this is 5, and this is 6, and this is 10. And the numbers or the picture is not to scale. And I want to know, so again, the missing side. What else is given? I have this angle is a right angle. Okay, and this is a right angle. And this is a right angle. Now, how to find the missing side? So here, I'm going to highlight 2 triangles I have on the picture. I have the bigger one. I'm gonna shade it blue. And I have the smaller one. Hold on. Let me use different color to be more visible. Let's use yellow. So here we go. So if you look at the yellow triangle, actually it's like pinkish beige. If you look at beige triangle, it's not enough information, right? We can't find one missing side knowing just one side. We cannot apply Pythagorean theorem. We cannot use trigonometric ratios because we don't have any angles given. So let's look at the blue triangle then. So for this triangle, we have 2 sides. We can find the hypotenuse. I don't think it's going to help us, but we also can find this angle. Let's call it angle Y. So if I know this angle, I can find the angle right next to it. And if I have an angle inside, I can find the missing x, the missing side. So let's start. Again, when you have 2 shapes right next to each other, start with the shape that has the most information. So for the blue triangle, we have the missing angle y, and in relation to this angle, what is given? We have opposite leg, and we have adjacent leg. So we have to use tangent. And then we write the definition. So tangent of this angle is the ratio of opposite leg over adjacent leg. And that will give us the angle. The angle should be around 59 degrees. So since these 2 angles form a right angle, I can find the angle right next to it. So 90 minus 59 is 31 degrees. So this angle is 31 degrees. So let's move on to the second step. Let's look at the beige triangle. We have, so let me use maybe black. So in relation to this angle, hold on. In relation to this angle, we have opposite leg and we have adjacent leg. So again, we have to use tangent, but this time we have the angle given. So tangent of 31 equals to, in the ratio, we have to put opposite first up and over adjacent. So adjacent goes down. Now we have a proportion that we need to solve. I'm going to use a shortcut. So I'm going to, in order to find x, I'm going to multiply 2 numbers across and divide by number opposite to x. So x equals to 5 divided by tangent of 31. So put it on your calculators. You should get about 8 3/10. And whatever unit you have. Okay, so that's it for this video. And please watch the previous videos if you still need help with trigonometric ratios.